Hi guys, here's a 5-minute course on Docker Compose for machine learning engineers. Let's get started. Why Docker Compose? Docker is great because it makes your machine learning code 100% portable from your local development environment to the production environment where it's going to run, for example, a Kubernetes cluster. However, Docker alone is often not enough when you're developing real-world machine learning applications. And this is because machine learning applications are not all-in-one monoliths that you can Dockerize into a single container, but a set of independent services that communicate through a shared message bus. This is the microservices way of building software that obviously applies to machine learning as well. So you need a tool to define, build, and run locally multi-container apps. And this is precisely what Docker Compose helps you with. Let's go through a step-by-step example. Let's develop, build, and run a real-time feature pipeline locally with the help of Docker Compose. Our real-time feature pipeline has 3 steps. There is a trait producer that connects to the Kraken API and saves this raw trace into a Kafka topic. There's a second step, which transforms these raw traits into so-called 1-minute candles and saves them into another Kafka topic. And then the third step takes these final features from the message bus and saves them to an external service, in this case, a feature store. From there, your machine learning models can later use these features both at training time and at inference time. Each of these steps is implemented as an independent service, and communication between them happens through a message bus, which can be either Apache Kafka or Red Panda. Let's now fully Dockerize this stack using Docker Compose in 4 steps. Step 1. Write a Docker file for each of your services. Docker file completely defines the environment in which each of these services is going to run. Docker files are defined by layers, starting from the base layer, from which you start adding transformations, and you end up adding the entry point, which is the default command that will run when you spin up the container. In between, there are essentially build steps, which are copying files and installing the necessary dependencies for your code to run. Step 2. Write the Docker Compose YAML file. The Docker Compose YAML file is a file that you write and commit at the root of your directory. In the Docker file, you specify the list of services that you want Docker to build and run for you. In this case, for example, we have 5. 3 of them are the 3 steps of our pipeline, and then we have 2 extra services that we need to run Red Panda locally in our computer. This is the message bus. Now, for each of these services in your Docker Compose YAML file, you need to provide extra instructions on how to build the Docker image. So, for example, you need to pass the path to the Docker file to build that service. And second, you also need runtime instructions. For example, how many replicas of a service you want to run when you spin up the container. Or, for example, if you want to force restarting every time there is a failure in one of the containers. Step 3, you build your multi-container app. For that, you go to the root directory where your Docker Compose YAML file is, and from the command line, you run Docker Compose build. With this command, you will build all the Docker images that you specify in your Docker Compose file and set up the necessary networking for them to communicate. Step 4, you spin up your multi-container app. For that, you go to the command line and write Docker Compose app. And if it works, you are done, because this is the magic of Docker and Docker Compose. If it works on your computer, it will also work in production. That's it for today, guys. I hope you learned something new. And if you want to get more hands-on, real-world, machine learning, production-ready, MLOps content for free every week, just subscribe to this channel.